This is a lecture on 10-1 on how to do this example on a calculator. So if you click under Stats and go under Edit, what you need is you need your X values in the L1 and your Y values in an L2. Notice this is an X comma Y pair, so there must be a dimension match within the X and the Y's, otherwise your scatter plot will give you an error message. Remember, to clear the list, you're gonna go up to a list, push clear, and then enter all of your values. Under Y is equal to, there's a stats plot. So what you need to push is you need to push second stats plot. What you need to do is you need to turn on the plot. So you're gonna push enter, and you're gonna say on, and it's asking you what is the type of a plot that you want. So we want this first one. The first one looks like a bunch of dots. That's the scatter plot. This is actually your ogive. This is your histogram, I believe. This is something that we didn't study in this class. It's called a box plot, and this one looks like a line plot, although I can't be sure, it's too small. So regardless, we need that first one. It's a scatter plot. It's asking you where are your x's, L1, where are your y's, L2, and it's asking what kind of a mark do you want. It really doesn't matter. And all you have to do is click graph. Now the chances are you won't see anything because the window needs to be adjusted to the right thing. So I'm going to click in here just to make sure that there is nothing else that's highlighted and plot 1 is highlighted. And I'm going to go into a window and make sure that the window has the parameters of my x's and y's, meaning the x looks like it ranges between 8.5 to be the smallest value and a 63 to be the largest. So in order for me to see all of the x's, I need to make the minimum less than the smallest number and the maximum to be larger than my highest number. Same thing, scale, keep it at 1. Same thing happens for the y's. It looks like my range is somewhere between 1.4 and 7. So maybe I'll go between 1 to 8, and that way I'll see everybody. So now if I push graph, I can see my scatter plot. So this is convenient. Under stats, if I'm going to go over to the test, in order for you to find the linear regression test, it's easier to actually go up, and it should be one of the bottom ones. It is called the linear regression t-test. We are using a t-distribution rather than a z-distribution. We can't use a normal distribution unless we really have lots of points. Before we get to lots of points, we have to resort to a more conservative normal distribution. So we're going to push this one, and really the only thing that it's asking you to do is it needs to know where is your list of x's. So by default it's L1. Where is your list of y's? By default it's L2. Keep frequency at 1, and we will be most likely be running a two-tail test. Notice there is your row. You can see it on the bigger screen. It looks like a funny looking P, so that's what I'm looking for on your papers. So either a P that kind of swings one way or the other way. So in our class, we will be using most likely a two-tail test. What you want to do is you want to push calculate, and there's a bunch of stuff that's going to come out. You'll need most of it once we finish 10-3. So running a linear regression t-test will actually give you way more information than what we need. As far as 10-1, you do need your t-test statistic. That's that first one. I'm going to be pointing on a bigger screen. So you need your t-test statistic. That's 10.39. You do need your p-value. That's the next value. That's this one is so small. It has an e to the power of -4, meaning times 10 to the power of -4. So this is a tiny, tiny little p-value. It's less than 1%. It does spit out a degree of freedom. And then it gives you a few things that we're going to study in 10.2 and 10.3, and particularly A, B, S. Those are your coefficients of your linear regression line. The S is that standard error that we're going to discuss in 10-3. R squared is the coefficient of determination, which is going to be studied again in 10-3. And that last piece of information, that's the R. That's the correlation coefficient that is studied in 10-1. So this particular menu actually guides you through all of sections of chapter 10. So when you're going to be doing homework on this chapter, the chances are you will not want to break this up into section. What you want to break it up is by problem numbers, because you notice that 10.2 is actually calling out a problem in 10.1, and 10.3 is calling out a problem in 10.1 as well. There might be a different way of organization of this homework than what you've been doing in the past. Regardless, you do have your few pieces of information. The R is that 90.982, or if you want to give me a few decimal places, it's still 2. 1, yeah, still rounds up to a 2. And if you go up, the test statistic and a p-value is what you need in order to run the test. The p-value is so small, it is definitely less than any possible alpha that they can present us in this problem. Therefore, definitely reject the null hypothesis. There is a linear relationship. 0.98 is a pretty close number to a 1. So this is where we leave this section, and we're going to move on to 10-3, where you'll notice that I will be using exactly the same example and going through a similar menu again.